Hi, good day, and welcome to my video on the popular types of sequences found in the CXC exams. All right, now these types of questions usually come in like question 7 or 8, where they give you a kind of puzzle or a puzzle question, and you have to try to find a pattern. So there are many different types of patterns. I think it will be impossible to cover all the types of patterns that could possibly come. But however, the way around this is that we could actually do the most popular ones and then do some past paper questions to practice not only the popular ones, but to see the other types of patterns out there. And my guess is if we do enough practice, you're going to be able to identify a sequence or a pattern on your own. Because the truth is, there's really an infinite amount of patterns someone can come up with. So let's go through the different types of patterns, the popular ones. There's one called the arithmetic progression, one called the geometric progression, the Fibonacci sequence, and of course the triangular sequence. We're going to start off with what is an arithmetic progression, also known as a linear progression. So I'm going to scroll down and you're going to see a sequence of numbers: 3, 5, 7, 9, and 11. Do you think we can guess the next number in this sequence? You think you can identify the pattern here? Well, in an arithmetic progression, you have to do a little test. All you have to do is look at the number and then look at the number just before. So over here, this number is 5. So let me just circle this here. Right. So this number here is 5. The number just before is 3. If we take 5 and minus 3, we will get how much? 2. Let's try the 7 and look at the number just before the 7. Take the 7 and minus the number just before, and you notice we will get 2 again. Let's take the 9 and look at the number just before. That's 7. Take 9 and minus 7 and we get 2 again. I think that you see the pattern here. In other words, the numbers are increasing by 2. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, and of course, if we wanted to guess the next number, 11 plus 2 would be 13. What do you call this number that it's constantly increasing by? That is actually called your common difference, okay? So let's give me a few seconds, let me just... Right, that's actually called your common difference. And the symbol for the common difference is the letter D, an appropriate letter. So let's go through here, right? So we just identified that the common difference is 2. Let me just clear up here a little bit, right? This will take a little while to explain. Notice the first number here is 3. So we call this T1, term 1. The second term is 5. So you call this T2. And 7 would be T3, then T4, and then T5. You see the little subscripts here? The 1, the 2, the 3, the 4, and the 5? That's actually the letter N. So the next number we know is 13. He would be T, and his subscript or N value would be 6. He is the 6th term. A little note here. Another name for T1 is the letter A. T1 has a special letter. You don't get to call T2 B or T3 C. T1 is also known as A, the first term. So let me show you how to use this formula here. Let's say we wanted to figure out T7, the 7th term. Now, I know you could figure this out and it would be 15. But let's say somebody didn't figure out that. We could actually use this formula here. to figure out the 7th term. So let me write it. Well, I'm going to write the formula here. 1 second. Tn is equal to a plus n minus 1 multiplied by d. We want to find the 7th term. So we want to find T7. So that means my n value is 7. So anywhere I go in this formula and I see an n, I can replace it with 7. According to the formula, we need a. How much is a? A is the first term in the sequence, so it's 3. Plus, n is 7, because we're trying to find the 7th term. So the formula says we have to minus 1, and we know the common difference is 2. The common difference is found by taking the number in front and minusing the number just before. And for it to be an arithmetic progression, every time you do that, you take the number and minus the number behind, you're supposed to keep getting the same answer over and over. So let's calculate T7. This is 3 plus 7 minus 1 is 6, and we have a 2. So T7 is 3 plus 6 by 2 is 12, and as predicted, this number will be 15. So my 7th term would be 15. But let's say we wanted to go even further. Let's say it had an 8 term, a 9 term, a 10 term. Let's say we wanted to find the 99th term. I am not going to add 2 and 2 and 2 and 2 until I reach the 99th term. And that's where this formula comes in really becomes handy. Because if we're trying to find the 99th term, we just go to the formula. A is how much? 3. Plus, we're trying to find the 99th term. So n is what? 99. We have to minus 1. And the common difference for this particular arithmetic progression is 2. So 3 plus 99 minus 1 is 98 multiplied by 2. Right, I'm just going to work this out on my calculator. Well, actually, I think I have my calculator over here, if I'm not mistaken. Yes. 98 multiplied by 2 gives us 196, and then we add the 3. And we get 199. So my 99th term is 199. Now, one thing about this formula, I've noticed in one particular past paper, sometimes they don't call it Tn, like to find the first term or second term. They might call it Un. Tn and Un is the same exact thing. A is the first term, better known as T1, but sometimes they don't call it A or T1, they call it U1. So the 1 stands for the first term, and everything else is pretty much the same. So these two formulas here are the same. I just wanted to mention that because it could confuse you in like later on when you're doing a past paper. Let's look at another sequence of numbers here. Look at the red numbers here. Let's look for a pattern. I mean, it takes a little bit of trial and error, but over here it looks like the number is always increasing by 5, and I think so. But let's just make sure. If this is really an arithmetic progression, take one of the numbers. Let's take this number here, right? And let's minus the number just behind. So it will be 10 and minus the number just before, 5. 10 minus 5 is 5. Let's do a couple tests just to make sure. Take 15 and minus the number just before. 15 minus 10 is 5. And let's do one more to make sure. Take the 20 and minus the 15 and we get 5 again. So we just do the check a few times, okay? Just to make sure. So the numbers are increasing by 5. So far, how much terms do we have? Let's see how much terms we have. We have one term here. So I'm going to call him T1. This is T2. This is T3, T4, and T5. Let's say we wanted to find the 66th term. Well, let's write the formula. Tn is equal to A plus n minus 1 multiplied by d. D is the common difference, the difference between all of the numbers. And the number is 5 because each of these numbers differ by 5. We want to find the 66th term. So that means A is my first term, which is 5. That's T1. N is 66. So I'm replacing any n's I see with 66. And my common difference is 5. 66 minus 1 is 65. Let's work this out. So in the brackets, I have 65 multiplied by 5. And then I add this 5 after. And I get 330. So that means my 66th term, if I keep counting in 5s, will be 330. All right. So I'm going to do one more example. Let's see if this is really an arithmetic progression, the blue set of numbers here. Let's take the number here. 1 second, pen is giving a little trouble. All right. Let's take the 3 and minus the number before. 3 minus 6 is minus 3. Let's take the 0 and minus the number just before. 0 minus 3 is minus 3. Let's do one more. Minus 3 minus the number before. Minus 3 minus 0 is minus 3. Let's do one more. That's for fun. Minus 6 minus the number just before. Minus 6 minus the number just before. The next number has a minus sign. So 2 minus will touch here to become a positive. So minus 6 plus 3 gives us back the minus 3. So that means each of these numbers differ by minus 3. So the common difference is definitely how much? Minus 3. So this is T1 here. This is T2, T3, T4, and T6. Let's say we wanted to find the 58th term. So let's write the formula. Tn is equal to A plus n minus 1 multiplied by d. We want to find the 58th term. So that means n is 58. My first term A, my first term in the sequence is 6 plus n minus 1. Well, n is 58. We have the minus 1. And the common difference just happens to be minus 3 this time. Let's work this out. So we end up with 6 plus 58 minus 1 is 57 multiplied by minus 3. So I could probably type this in straight on the calculator. I have brackets and everything. 6 plus open brackets 57 close brackets multiplied by minus 3 close brackets. And I get minus 165. So my 58th term, if I were to keep minusing 3 until I reach the 58th term, would be minus 165. Okay. Now, for those who didn't understand the calculation there, if I work out the 57 and the minus 3 first, 57 multiplied by minus 3, you realize, well, a positive and a negative is a negative, so you get minus 171, and then you have the annoying 6 here. 6 minus this, minus 171, will give us minus 165. So that's how you identify an arithmetic progression. The numbers will be increasing by a constant amount or decreasing by a constant amount. So the next type of progression is a geometric progression. Now, the formula for a geometric progression, like to find the next term, is a r n minus 1. Yeah, I'm guessing you already know that a is the first term. And you can make the comparison between the two versions of the formula. But what does the r stand for? Remember, in an arithmetic progression, the one we did just before, the difference, there should be a common difference. But let's see if this is an arithmetic progression. Let's just see. Let's take the number here and minus the number before. 40 minus 4 is 36. Let's take the 400 and minus the number just before. 400 minus 40 is 360. You notice we didn't get the same number. And if we take this and minus the number just before, let me do that. I should be able to do that in my head, but I can't. 4,000 minus 400 is 3,600. Clearly, these numbers are not the same. I know 36 looks like 360, but this is clearly has a 0 here, and this one has 2 extra zeros. So this cannot be an arithmetic progression. If it was an arithmetic progression, we would get 36 all of the time, exactly 36, not 360, not 3,600. So we need to find a next pattern. So how would we figure out what the next number is? Well, in a geometric progression, if you take the number in front and divide it by the number after, you're supposed to get the same number. 40 divided by 4 is 10. Let's try the 400 and the number just before. Take 400 and instead divide it by the number before, and we get 10 again. Take the 4,000 and divide it by the number just before. 4,000 divided by 400 is 10. This is a geometric progression. When you take a number and divide it by the previous number, you always get the same number. That number is R. That's your common ratio. All right? So that's your common ratio there. All right, just 1 second, guys. I guess I could just scroll down here. Now, the common difference is represented by the letter R. So let's go over here. I don't know why this thing is giving so much problems. And we just have to work with it. All right. So the common ratio is represented by the letter R. 1 second, guys. It's a bad time to stick. All right, everything should be better there. I was using 2 screens. I guess that was causing the problem. Okay, so your common ratio is what you get when you divide the number by the previous number. So my common ratio in today's question is R. Remember, this is T1, the 40 is T2, here's T3, and T4. Let's say we wanted to find the 7th term. How would we find it? Well, we're trying to find T7. To find T7, here's A, right? A is the first term, 4. And then the common ratio is 10. Now you have to be careful. This looks like 410. But A gets multiplied by R. And over here is n minus 1. Remember, n is 7. According to the formula, we have to minus 1. 7 minus 1 will give us 6. So Tn is equal to 4 multiplied by 10 to the power 6. Be careful. Do not multiply by the 10 and then put it to the power 6. This power 6 only belongs to the 10. So I usually work out that part first. 10 to the power 6 is that. Multiplied by 4 afterwards. And I get 4, looking like 6 zeros if I'm not mistaken. 1, 2, 3, 4, 5, 6. So that would be my 7th term. It's really, really, really simple. Okay? So that's a geometric progression. Oh, let's see, we have another example here. Okay, so here we have another geometric progression. Let's make sure it's a geometric progression. Let's take the number in front and divide it by the number before, sorry. So take 3 and divide it by 9 and we get 1/3. Take 1/3 and divide it by 3. 1/3 divided by 3 will give us what? 1/3 divided by 3. We don't get the same thing. We get 1/9. And if we take this 1/9 and divide it by 1/3, 1/9 divided by 1/3, well, 1/9 divided by 1/3 gives us actually 1/3. We need all of them to be the same. I got a 1/3 here and a 1/3 here. But when I took the 1/3 and divided by the 3, I did not get 1/3. So this is not a geometric progression, which means I cannot use this formula. And this is definitely not an arithmetic progression, because I know if I take 3 and minus 9, it's not going to give me the same answer as if I take 1/3 and minus the 3. All right, so I honestly think that when I was making this question, I made a mistake, but we did learn something from it. It's always good to do a test to make sure whether it's an arithmetic progression or a geometric progression. And it's a good idea to do the test more than one times, because if I only did this one and then I skipped the middle and did this one, I would have thought it was a geometric progression. All right, so moving on. Right? Don't worry, guys. You're gonna get so much practice when we're doing the past papers. I'm gonna keep going back to the formulas. Okay, so here we have the Fibonacci sequence. This one here, you're not gonna get any like formulas or anything to calculate the first term or second term. It's just a pattern you need to realize. I'm not too sure if you see the pattern here. In this type of series, right, the Fibonacci, you have to start off with 2 numbers. You must be given at least 2 numbers. The first 2 numbers are 0 and 1. You don't have to worry about how you got the 0 and the 1. So this is the first term, T1, and this is the second term, T2. To get T3, right, you just have to add these 2 numbers. 0 plus 1 is 1. To get him now, you have to add the 2 previous numbers. 1 plus 1 is 2. To get the 3, you add the 2 previous numbers, the 2 numbers that just came before. 2 plus 1 is 3. Let me just do it a couple more times. To find this number, you add the 2 numbers before. 3 plus 2 is 5. And to get this number, you add the 2 numbers before. 5 plus 3 is 8. And if we do that, we'll get, here's supposed to be, to get it 13, you add the 2 numbers before. 5 plus 8 plus 5 is 13. So let's try another one. Let's start off with 3 and 7. What would be the next number? Well, to get the next number, you add the 2 numbers before. 7 plus 3 is 10. To get the next number, add the 2 numbers before. 10 plus 7 is 17. To get the next number, add the 2 previous numbers. 17 plus 10 is 20. I think you get the idea here. Right now, you just have to look out for this sequence. It takes a little bit of practice to identify it, but like I said, we will get the practice as we go along. Okay. Right. The last one here is the triangular sequence. Now, not everything that looks triangular is a triangular sequence, right? Now, you're going to realize that when we're doing the past papers eventually. But here are 2 examples of 2 sequences that I'm sure are triangular. What we do, we have a red circle here. So this is term 1. Term 1 has how much circles? It has 1 circle. Term 2, right? You notice where we add 2 circles underneath. Term 2 has how much circles? 3. 1, 2, 3. The third term, right? We add a next row of circles underneath that. How much circles does it have? 1, 2, 3, 4, 5, 6. This here is a triangular sequence. Now let's say I am too lazy to count up how much circles it have here and count up how much circles it have here. I can actually use this formula on top here. So if we want to figure out how much circles it have in the fourth term, well, T4 means n is 4, the fourth term. So let's use the formula. 4, replace the n with 4. Inside the brackets is another n, so put the 4 again, plus 1, and the formula says to divide by 2. Let's work out the brackets. 4 plus 1 is 5, 5, and we have to divide it by 2. 4 by 5 is 20, 20 divided by 2 is 10. Let's see if we're correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we are correct. If we wanted to find T5, like how much circles it had here, let's go back and use this formula. T5 is equal to, well, we are assuming n is 5 because it's the fifth term. 5 plus 1 divided by 2. 5 plus 1 is 6. 6 by 5 is 30. 30 divided by 2 is 15. Let's see if we're correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's a triangular sequence. And sometimes the circles are sometimes just stacked a little bit different. It is pushed around. But the top and the underneath here are clearly the same amount of circles, right? They're just rearranged slightly different. So don't let it get to you. Okay? So guys, those are like 4 popular sequences. I'm just wondering if there's another, like sometimes there are patterns like these here, simple ones, like you might see a number 2, and then you will see 4, and then you will see 16, right? And then you might see 256, and you're probably wondering what is the next number. Now it takes a little bit of trial and error. You notice if you take 2 and you square it, right? Let's see what kind of sequence this is. I just made it up on the spot. Is it an AP? If we take 4 and minus the number before, we get 2. If we take 16 and minus the number before, we get 12. We got 2 different numbers there. So it's definitely not an AP. Is it a GP? Let's take the number and divide it by the number just before. 4 divided by 2 is 2. Let's take 16 and divide it by the number before. 16 divided by 4 is 4. Not the same. And if we take 256 and divide it by the number before, 256 divided by 16 is actually 16. So even when we divide it, we still don't get the same number. So it's not an AP, it's not a GP, this definitely isn't a triangular, and it's not a Fibonacci, right? Because 4 plus 2, like if you wanted the 16, and 4 plus 2 is supposed to give you the 16, so it's not that, okay? So what is the pattern over here? There must be a pattern. I don't know if you picked up on it, but you're just squaring the previous number. 2 squared will give us 4. 4 squared will give us 16. 16 squared will give us 256. So how would you get the next number? To get the next number, you have to take the 256 and do what with it? You have to square it. So to get the next number is 256 squared. And if we do that, I have a feeling we'll get a really big number. 256 squared is equal to, wow, 65536. So I really don't have a name for this pattern. It's just, I realize that if you square it, you will get the next number. You take each number and square it, you get the number in front. So sometimes, like I said, I know saying it over and over, it takes a little bit of trial and error and a little bit of practice to kind of figure out the pattern or the puzzle. It usually doesn't come too hard in the exam, in my experience. So guys, I'm going to look for some past papers now, and we could probably try some out. Okay? So let's try a past paper question here with sequences. Let's scroll up here. All right. So apparently there's a hexagon in pattern 1 here. So let me just over here. Right. So you have one hexagon here. Apparently we're using sticks to create the pattern of the hexagon. So in the first one, if you notice, we have how much sides? 1, 2, 3, 4, 5, and 6. But they have it in the table here. For the first hexagon, it takes 6 sticks. And then for the second pattern, which is 2 hexagons together, apparently it takes 11 sticks. And for the third one, that's this one here, it takes, if we count up all the sticks, they are telling us it will take 16. So immediately, let's start looking for a pattern here, right? So let's start looking. I just want to scroll along a little bit so you can see the values here better. Let's look for a pattern. Is it an AP? Is it an GP? Is it a Fibonacci? Fibonacci? Is it a triangular? Let's see, or is it none of them? Let's try the AP first. If we take 11 and minus the number just before, 11 minus 6 is 5. Let's try the 16 now and minus the number just before. 16 minus 11. Luckily, we got 5. We got the 5 twice. So I have a good feeling this is an AP. But it is an AP, I'm pretty sure. Remember the formula for an AP is what? Tn is equal to A plus n minus 1 multiplied by d. Our first, this is T1, T2, but this is the n value here. N is 1, n is 2, n is 3. And our first term, when n is 1, the actual value is 6. So that means A, our first term, is 6. And our common difference is 5. Remember how we got the 5? We took the number and minused the number before. So we have, basically, this is our how our formula looks now. We know A is 6, n minus 1, and our common difference is 5 for this particular pattern. In the question, they want us to find the values of x, y, and z. So I have a good feeling we're going to have some algebra to do. Let's get started. Let me change the color here. The blue is getting a little more. Let's find x here. X is when the n value is 4. So we are trying to find the value of x when n is 4. So we're trying to find T4. If we're trying to find T4, we know A is 6. The n value is 4. So it's 4 minus 1. And the common difference is 5. So let's work this out. 4 minus 1 is 3. 3 by 5 is 15. 3 by 5, I need my calculator here, sadly. 3 by 5 is 15, plus 6 is 21. So it's 21. So if a fourth hexagon was added here, it would take how much sticks? 21 sticks. Now, why? Right? It is a repeat of what we just got here. We want it when n is what? 5 instead of 4. So if it had like a fifth hexagon added in, how much sticks would it take? So we're trying to find the fifth term here. We're just going to use back the formula up here. A is 6 plus n is 5. So it's 5 minus 1. And the common difference is 5. 6 plus 5 minus 1 is 4. And we have a 5 waiting on the outside here. All right. So 4 by 5 is 20 plus 6 is 26. So when there are 5 hexagons, you can expect 26 what? Matches. Okay? And well, once you realize it's an AP, so the numbers are just increasing by what? 5. So if it didn't want to use the formula, not a problem, okay? Because these numbers were so close. It was the third term, fourth term, and fifth term. You notice 16 plus 5 is 21. 21 plus 5 is what? 26. Okay? So let's erase that. Because we have the 26 up there. Now, notice they wanted the first term. They have the first term, second term, third term, fourth term, fifth term, and they jump to the 20th term. So they try to catch you here. I mean, you would think 6 would go here, but they skipped. So they want you to find the 20th term. And this is where the formula definitely comes in handy. Tn is equal to a plus n minus 1 by d, because it's an arithmetic progression. So we want to find T20 is 6 plus n minus 1. N is 20. So we get 20 minus 1. And the common difference we figured out was 5. Remember, we knew the common difference was 5. And we've been using 5 right through. So let's work this out. T20, 6 plus 20 minus 1 is 19. 19 by 5. Let's work this out on my calculator. 19 multiplied by 5 plus 6. I'm getting 101. So when there are 20 hexagons, you can expect there to be a 101 matches. So now in the next part of the question, in part B, where we found, look at it, we found X, we found Y, and we found Z. We have it up here, 21, 26, and 101. Part B, write an expression S in terms of N, where S represents the number of sticks. Remember, Tn is equal to A plus N minus 1 multiplied by D. And all they're asking us to do is that instead of calling it Tn, they want us to call that S. Okay? A is how much? 6 plus n minus 1, and the common difference is 5. So they just wanted us to kind of update this formula. Instead of calling Tn, they want us to call it S. We know A is 6, and we know D is what? 5. So that means this formula, we can use this formula to find the amount of sticks once the examiner tells us the value of n. Now, don't get me wrong, we could simplify this formula if you want to. If you want to expand the brackets to simplify it for the examiner, feel free. Everyone inside the brackets here gets multiplied by 5. So n by 5 is 5n, minus 1 by 5 is minus 5. And if you simplify it, 6 minus 5 is 1 plus the 5n. I think this is the better answer here. I think we should have simplified it for the examiner. So that's part B. All right. So let me scroll along here to make space to work the next question. Bianca used a total of 76 sticks. So this time, we know how much sticks it has. So let me write my formula one time. Tn is equal to A. But actually, we don't have to use this formula again, because remember, we simplified the formula. S is the amount of sticks is equal to 1 plus 5n. Remember, when we simplified this formula, we got this formula. So both formulas are the same formula. So let's just work with the simplified version. So now in part C, we know how much sticks it has. It has 76 sticks. 1 plus 5, and they want to know how much hexagons it will have in order to have 76 sticks. So instead of number n is basically how much hexagons it have. Remember, when this was term 1, it had 1 hexagon. When it was term 2, it had 2 hexagons. This is term 3. It has how much hexagons? 3 hexagons. So that means n is the term as well as the amount of hexagons it have. So they're already asking us to find each. They're kind of backtrack. So let's solve for each. Through across positive 1, we get minus 1. 76 minus 1 is 75. And this is equal to 5 each. The 5 is a multiply, throw it across, you get a divide. 75 divided by 5 is 15. So if we have 15 hexagons connected in this pattern, it will have 76 matchsticks. All right, guys. So I believe this was, let me see which year this was. Oh, yes, it was January 2010. All right, so let's go ahead and try another one. Let's try another past paper question here. Let's just scroll down and look for the question. All right, so this is a question here. You can notice there are triangles and they're getting larger and larger. Let's have a look at the table before we actually read the question. I just want to see what the table is saying here. You have figure 1, 2, 3, and 4. So immediately I know this is T1. This is T2, this is T3. So n is 1, n is 2, and n is 3. They're asking us questions on the area of the triangle as well as the number of pins on the base. Now the base will be here. So let's see if the table makes sense. The first triangle, the base has how much pins? 1, 2, and 3. Yep, it does have 3 pins. The next one has 1, 2, 3. 4, 5. Do they have 5 here? And just to confirm, 1, 2, 3, 4, 5, 6, and 7. All right, they have 7 here. Let's see if the areas of the triangle make sense here. For figure 1, they are saying that the area of the triangle is 1. The area of the second triangle is 2, and the third one is 9. Let's actually calculate the areas. I think I need to zoom in here a little bit. First of all, how do you find the area of a triangle? Let me use a cross here. The area of a triangle, the one that I think we're gonna have to use. Let's now, guys, let me just fix this here. The area of a triangle is base by height divided by 2. So let's try for the first triangle. How much is the base? You notice between here and here is one line. So I think that's a centimeter. So it's 1 centimeter, 2 centimeters. So the base is 2 centimeters and the vertical height is between here and here. That's 1 centimeter. So for the first one, the base is 2, the height is 1, and divided by 2. This will work out to 1. So I guess they were right that the area of the first triangle was 1. For the next triangle, what's the base? How much centimeters here? In between each dot is 1 centimeter. 1 centimeter, 2 centimeter, 3 centimeters, 4. So the base is 4 and the height is how much? Between each dot here, 1 and 2, right? So the area of the second one is base, which is how much? 4. The height is 2 and divided by 2. So we get 4. Is the area of the second one 4? Yes. So I guess it makes sense. And I'm guessing if we found the area of this triangle, we would get 9. So what they're asking us to do here now, what they want us to do is complete the figure in part A for a fourth triangle. Now I decided on the formula, on the answer sheet provided. Now I don't have the answer sheet on me, but we can just use this. You notice we're just always going down, like in this pattern here. You're going down in this pattern here. So for my fourth figure, all I need to do is just go down one more like this. So that's the pattern I notice. And then this could be the base. 1, 2, 3, 4, 5, 6, 7, 8, 9. How much pins will my fourth figure have? Well, it's supposed to have what? 9. It won't have 3, it won't have 5, it won't have 7, it will have 9 now. What will be the area of this new triangle, the fourth one? Well, it's T4, right? Between each pin is 1 centimeter. 1, 2, 3, 4, 5, 6, 7, 8. So the base is 8. Remember how you find the area of a triangle? Base by height divided by 2. So we know the base is 8. The height will be between here 1, 2, 3, 4, and the 5 here. So how much centimeters is that? In between each pin is 1 centimeter. 1, 2, 3, 4. So to find the area is base, which is 8. The height is how much? 4 divided by 2. 8 by 4 is 32. 32 divided by 2 is what? 16. So my fourth figure or fourth triangle would have an area of what? 16. Now, the question here, we have to fill out all the blanks, right? So, let me make this a little bit smaller so we can see everything. Let's look for a pattern here, right? Now, I have a good feeling this is not going to be an AP or a GP or anything like that. We know it's not an AP. Well, for this one here, part is an AP, but because look at this. There are two sections here. One, they're discussing the area of the triangle, and one of them is the pins. For the pins, take the 5 and minus the number above. 5 minus 3 is 2. Let's put it here. And then we have the 9. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2, right? So the difference between each successive number is 2. So this over here, the base of the pins is definitely an AP, all right? However, I don't even think we need to go to the formula, even though we can get this out using the formula for an AP. But look at this, right? You notice the pattern here. The formula to calculate the number of pins on the base. You notice this number is always 2, 2, and 2. So I think the formula down here will have a 2. 1, 2, 3. It's no coincidence if it's figure 1, this number is 1. It's no coincidence if this is 2, over here is 2. If it's figure 3, this number is 3. So if we are talking about figure 4, well then here has to be what? 4. And here's 1, here's 1, here's 1. So apparently you're always adding 1 after. And that will give us the 9. Now we could have used this formula to figure out the 9 instead of drawing it here and counting it here. I just want to prove it here. So we know the common difference is 2, because that's the difference between each number. And the first term, the first number of pins is 3. So A would be 3. So if we're trying to find T4, T4 is A. How much is A? 3. That's this guy here. Plus N minus 1. It's the fourth term. So that means N has to be 4. So it's 4 minus 1. And the common difference is 2. Let's work this out. It's 2, sorry. 4 minus 1 is 3. And we have a 2 waiting outside. 3 by 2 is 6. 6 plus 3 is 9. We would get back the 9 in any case. So we got the 9 two ways. By recognizing it was an AP. And also we could have just physically count the amount of pins at the base. Remember, we got 9 when we counted the pins. All right. So moving on to the next part of the question here now, right? Keep it in, or let's keep it in. For this column here, the AP column, A is 3, that's this here, and the common difference is 2. That's just in case we need to calculate anything else here. We're over here now. We have to fill out this column here. So if here's 100, right, what needs to go over here? Let's look for a pattern, right? I'm not too sure. Let's look at this column here. We have 1, 4, 9, 16. What is the pattern here? I guarantee that this is not an AP. 4 minus 1 is 3, but 9 minus 4. Sorry, 4 minus 1 is 3. 9 minus the number just before, which is 4, is 5. So clearly they're different already. So it's not an AP. It's definitely not an AP. It's not a GP, because if you take 4 and divide it by 1, if we divide this time, we will get 4. If we take 9 and divide it by 4, we will not get back 4. So you will not get back 4. That's not equal to 4. So it's not a GP. It's definitely not a I always have problems pronouncing that word, the Fibonacci series. And it's not a triangle. I don't believe. I know you're watching this here and you're thinking it's a because you see in a triangle. I wonder if it could be. No, it's not a triangular series, because it would have been triangular if we were counting up all the dots, like this dot, this dot, this dot, and everything on the base. It would be triangular. But you notice we are only interested in the dots on the base, not all the dots. And also this one is asking us about area. The triangular series really had nothing to do with areas. So what is the pattern here? You notice 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So what should go here to give us 100? 10, because 10 squared will give us 100. So let's fill out the pattern here. You must have a 2 here. If here is 4, then remember, if here is 4, over here has to be 4. If here is 3, over here has to be 3. So if here is 10, then over here has to be 10. And the formula always has a plus 1. 2 by 10 is 20. 20 plus 1 is 21. Let's work out the 20 now. 20, well, here has to be 400, because 20 squared is 400. Let's fill out the common pattern here. Here's 2. Here has to be 20 plus 1. 2 by 20 is 40, plus 1 is 41. All right? And a general formula for n, but then here has to be n squared. Here's always 2. Remember, if here is 20, then over here is 20. So if here is n, then over here is n. And then we always add 1. If we simplify this, we get 2n plus 1. And that's the end of that question. Now, I wanted to prove something, right? You see how we got this 41 here? If we wanted to use the arithmetic progression formula, we could have, if we wanted to. Because according to the arithmetic progression, remember this column here is arithmetic. A is 3. Over here, we're talking about which term? The 20th term. So that means we replace the n with 20 minus 1. And the common difference is how much? 2. 3 plus 20 minus 1 is 19, and we have to multiply it by 2. Let's work that out. 19 multiplied by 2 plus 3. And we got back the 41. The same exact 41. So I guess we could have, there's more than one ways to do this question. So guys, I really hope that you understood this question. Which year was this, by the way? This looks like June or January. I can never tell unless I scroll up to the top. Oh, this is June 2012. All right, guys, stay tuned for the next one. Let's do another question here on sequences. Here you have some triangles. Now immediately, well, I know this is supposed to be T1, T2, and T3. Term 1, term 2, and term 3. Draw figure 4. So they want us to draw figure 4, T4. Now I'm just going to continue the drawing over here in order to get T4 instead of me drawing it back, right? You realize it's just an extra layer. Here has one triangle and then one layer underneath here, and then it gets an extra layer underneath here. So all you're really doing is extending underneath here to make the triangle bigger. And you're just doing this, zoop, zoop. So you're looking for a little pattern. That's the best I can explain it. I don't know if you all saw that pattern. So the question is obviously going to ask things about how much triangles and whatnot it have. This one has one triangle. This one has 1, 2, 3, 4 triangles. T3, remember, before I extended T3, it had 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this one had 9 triangles. And now T4 would have, if we continue, 9, 10, 11, 12, 13, 14, 15, and 16. So he would have 16 triangles in him. Let's go down and see what the question is asking. Like after they ask us to draw the fourth sequence, let's go and see what they were asking. Remember, the first one of the columns here is talking about the number of triangles, and the other one is asking how much sides it have. Now we already know that this one here, remember this was T1, this was T2, this was T3, T4. Remember when we counted up the triangles, we got 16. That was this 16 over here. Now this column over here, the number of unit sides, they want us to count up the amount of sides. Now to tell you the truth, I don't mind for the first one to count up the amount of sides. It has 1, 1, 2, 3. For the next one, it has 1, 2, 3, 4, 5, 6, 7, 8, and 9. I am not going to count up the amount of lines in T3 and the amount of lines in T4. And the examiner does not expect you to either. Instead, he hopes that you recognize a pattern. I didn't even have to count how much triangles it had in the fourth sequence, even though I counted it up and it was 16. Because if I had looked carefully, and we saw this from the previous question, to fill out the numbers in this column, all you had to do was take these numbers and square it. Because 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared would have given me what? 16. So there was really no need for me to actually count up all the triangles. But I did it just in case, right? So quickly we could figure out what goes over here. What number squared will give us 144? I think we know the answer already offhand is 12. Let's fill out this column here, this one here. Okay, you will notice everybody has what? A 3. So I know that when I put in the pattern here, here has to be 3. 3 multiplied by what? You notice here is 1, 2, 3. So if here is 1, over here is 1. If here is 2, then to the right is 2. So if it's 4, I know here has to be 4. Close my brackets. You notice once again it's 1, 2, 3. So what do you think will go here? 4. Whatever you have over here gets repeated over here. And you notice you have a 1, a 1, and a 1. Clearly the 1 is constant. So plus 1. And the number underneath apparently is always 2. So you're looking for a pattern there. Right? So how much would I get over here? 3 by 4 is 12. 4 plus 1 is 5. Divided by 2. Alright, so 12 by 5 divided by 2, and I get 30. Well, let's double check that. 12 by 5. Yep, we get 30. Now, over here, I doubt, I'm not seeing any pattern from just looking at it. This from here to here to here to here doesn't look like an AP. It's not a GP. Because if we take this number and divide it by the number just before, and then take the 18 and divide it by the number just before, which is 9, we're not going to get the same number. I know I spoke about triangular series. Remember a triangular series, and I haven't used it as yet. This was the formula. I don't think this is going to be a triangular series either, Because if it was a triangular series, right? Let's erase something here. If we wanted to find the amount of sides when n is 3, that is what? T, 3. We're assuming n is how much? 3. So we're going to replace all the n's with 3 and then divide it by 2. 4 plus 1 is, 3 plus, I said 4 plus 1 is 3 plus 1 is 4. 4 by 3 is 12. 12 divided by 2 is 6. You notice we did not get 18. If we got the 18, like if we had used this formula here to calculate everything in this column here, then and we got the answers, but then I would say that it's a triangular series. But it's not a triangular series. Instead, we just have to look for patterns, like what numbers were the same coming down. You have to look for numbers that were the same coming down, or if they change a little bit, to look at the patterns they were changing in. So over here now, let's fill out the rest of this column here. So apparently, here's always 3. 12 needs to go here. 12 needs to go here also, plus 1, and then you divide it by 2. Remember, this number and this number here matches up to this number. Apparently, the 3 and this 1 never change coming down the column. Also, the 2 never changes. So if we work this out, we will get 3 multiplied by 12 multiplied by 13 divided by 2. I get 234. I got the 13. 12 plus 1 is 13. Okay? So that's the answer I got over there. 243. Sorry for the bad handwriting, but it's really hard to write with this this whatever you call this, a tablet pen or whatever. All right, so what goes over here? To figure out what number goes over here, we have to square the 25. I think we see the pattern. 25 squared is 625. We know the pattern for this column here. Open brackets, here's always 3 multiplied by 25. 25 plus 1 divided by how much? 2. Right, and let's double checking something here. Right. 25. Right. So let's work that out on the calculator. So I know 3 by 25 is 75. 25 plus 1 is 26. We have to multiply those two and divide it by 2. So it's 75 multiplied by 26 divided by 2. And I get 975. So let's fill out the last row, sorry. If here's n, over here has to be n squared. The general formula is you always have a 3 here. You put an n here. Whatever you have here goes over here. It also goes over here too. Plus 1 divided by 2. And that's the formula they were looking for. And that's the end of that question. Okay, guys? So let's scroll up. Which year is this? This is May, June 2015. All right, guys. I'm going to look for another question to do there. Let me see what I can find. Try another question. Here we have figure 1, figure 2, and figure 3. So by now, you know this is T1. Oops, forgot to put on T1, term 2, and term 3. And they want us to draw the fourth sequence. But I guess you see it's like kites stacked up next to each other. So the fourth term, right? Now I'm just going to continue term 3 in order to draw term 4. I'm too lazy to draw back all 4 here. So you would just, this is all we have to do. We just have to draw in a fourth one. Believe it or not, it's really that simple. Right? And this entire diagram would go over here. Okay, so they give you space to draw all 4. It doesn't really get easier than that, but that's completing the diagram. Now I went ahead and I read the question, and they're gonna be asking you questions on the amount of dots on each diagram plus the amount of sides making up each one. It's going to be a headache to count every single side and of course every single dot. But I really doubt that is what the examiner wants you to do in any case. Instead, he hopes that you see a pattern. So this column here is the amount of dots, and this one here is asking you for the amount of lines. Now look at these values here. Look at 4, 7, and 10. Look at those numbers. If you take 7 and minus the number before, 7 minus 4 is 3. If you take the 10 and minus the number just before, 10 minus 7 is 3. You notice you get the same exact number. So this is an AP. That's definitely an AP. The number of lines, that's over here, right? That's the second one. I don't know why this pen is giving so much trouble. All right. The second column, which is here. Take the 11 and minus 6. 11 minus 6 is 5. 16 minus the number before, 16 minus 11 is also 5. Lucky for us, this turns out to be another AP. So for the first AP, right, let's get the values of A and D. So we can just use them whenever we need them, right? So I'm going to change the color here. Let's use this here. For this column, for the one with the number of dots, right? A, what's going on with this pen? 1 second, guys. A will be 4. That's the first term. Actually, let me go on. Let me write this somewhere else. This is going to get confusing if I have too much things written in one place. Okay. So for the dots, sorry guys, I'm a little sleepy here. So, all right. So for the dots, that's this column here, the one with the dots. A is how much? The first term will be 4. Remember, the first term is 4. How much is the common difference? The common difference is 3. All right. And for the one with the lines, that's this one here. The first term, A, is how much? 6. And the common difference is 5. So at least we have the information for each AP. It's 2 different APs, each with its own A value and its own what? D value. So we need to fill out this column now. The one with the 4 here. Now, let me change the thickness of this. I don't think that's a good idea right now. All right. Sorry guys, this is giving a little trouble. Just bear with me here. All right. So to fill out this one here, we should probably use, well, the formula we have to use is what? Tn is equal to what? Tn is equal to A plus n minus 1 multiplied by what? D. So if we know the term is 4, that means n is 4. So T4 is equal, the A value is 4 plus n minus 1. So it's 4 minus 1 and the D value is 3. So T4 is equal to 4 plus 4 minus 1 is 3. And we have a 3 waiting on the outside. 3 by 3 is 9. 3 by 3 is 9. 9 plus 4 is 13. To get this value now, we have to use these values for the AP. So once again, Tn is equal to A plus n minus 1 multiplied by D. For the lines, the A value, the first value is actually 6. But I have it up here too. Plus n minus 1, remember, is T4. So it's 4 minus 1, and the common difference this time is 5. So it's 6 plus 4 minus 1 is 3 by 5. So 3 by 5 is 15. 15 plus 6 is 21. So all we're going to be doing now, guys, is we're just going to be using the AP formula. That's all we're going to be using, okay? And we're going to repeat this for the 10. So let's go ahead and do it, right? So I have the values quite up here. For the dots, A is 4 and D is 3. So let's just try to remember that. For the dots, A is 4 and D is 3. And they want us to find T10 over here. T10 is equal to A plus N minus 1 by D. A is 4 plus, well, N is 10. So 10 minus 1, and the common difference is 3. 4 plus 10 minus 1 is 9. And we have to multiply by 3. 9 multiplied by 3 is 27. 27 plus 4 is 31. Now we have to figure out this one here. T10 again, but this time, remember, the A value and the D values are different. It's 6 and 5. So A is 6 and D is 5. A plus N minus 1 by D. A is 6. N minus 1, well, 10 minus 1. And D is 5. 6 plus 10 minus 1 is 9, and we have to multiply by 5. 9 by 5 is what? 45. 45 plus 6, I believe, is 51. And that's all we're doing. And over here now, it's a little bit reversed, okay? We need to figure out this here. So let's write it back. Tn is equal to A plus N minus 1 by D. For the first one, A is 4, D is 3. 1 second. So we know A is 4, N minus 1, and D is 3. And this time we're trying to find the term, right? No, sorry, they gave us we are trying to find the term, right? But the term this time is 49. We just don't know if it's the first, fifth, sixth, or 10th term. In other words, we're trying to find what? N. That is what we are trying to find, the value of N. So what we have to do now here is solve for N. It's pretty easy. Let's multiply the brackets. We have 49 is equal to 4 plus everyone inside this bracket gets multiplied by the 3. 3 by N is 3N minus 1 by 3 is minus 3. So we get 49 is equal, well, 4 minus 3 is 1. And then we have this plus 3N here. Throw across the positive 1. You get minus 1. 49 minus 1 is 48. This is equal to 3n. The 3's are multiply. Throw across the multiply, you get a divide. So 48 divided by 3 is 16. So over here is supposed to be 16. And now they want us to find this. Now, over here. For the lines, but remember for the lines, A is how much again, and D is how much? I keep forgetting. Just a little bit sleepy here. For the lines, A is 6 and D is 5. A is 6 and D is 5. So Tn is equal to A plus N minus 1 by D. Tn is what we are trying to find, but it's actually T16 we are trying to find. We now know it's 16. A is 6 plus 16 minus 1. I think we can do this in our head now. 16 minus 1 is 15, and the common difference is 5. Let's just quickly work this out. 15 multiplied by 5 plus 6 is 81. 1 second. Right, so we have that down. And now they're looking for the general formulas. Anytime you're trying to calculate a term, right? Remember, let's see. Where can I write? I want to write it over here. Remember, for this column, A was how much? 4, and D was how much? 3, if I'm not mistaken. Yep. So to calculate anything here, the term, we have to use the formula Tn is equal to A plus n minus 1 by D. Usually we know the value of n, but this time n represents a value, like it could be 100, 200. So we don't know the value of n. We're just going to replace n with capital N. A is 4 plus capital N minus 1, and the common difference is what? 3. We could leave it like this, or we could just, I think we should simplify it out for the examiner. 4 plus everyone inside here gets multiplied by 3. So it's 3n minus 3. Right? 4 minus 3 is 1 plus 3n. So the general formula after we simplify it is 1 plus 3n. And guess what? We're going to do the same thing for the next one with A as 6 and D as 5. So number A is 6 and D is 5. Oh, run out of space here. So Tn is equal to A plus n minus 1 by D. We know A is 6, n is capital N, right? So n is capital N minus 1, and the common difference is 5. So we end up with 6 plus, multiply everyone in the brackets by 5, you get 5n minus 5. 6 minus 5 is 1, so you get 1 plus 5n. And that's the end of that particular question. This question was just about using the AP formula over and over and over, because it was an AP series. Okay, so I guess they got fed up of hearing me using the same formula over and over and over with just different values of what? A and D. Alright guys, now I know this was a lot to take in, but I really hope that this video was helpful. I think I did the hardest questions out there. I've seen much easier questions come than this. And guys, thanks for watching. Don't forget to like, subscribe, and of course comment. And of course, if you're from Trinidad and Tobago and you need any extra lessons, my number can be found in the description. You could just give me a call, and I'll send you a price listing for the classes and the timetable and whatnot. Thanks for watching, guys. Have a good day.